Okay, so we are moving on to area of regular polygons. Okay, so the first bit of this is just some vocab. So a regular polygon, remember, it has all of its sides are congruent. It has to be convex, which means there aren't any dents in it. It can't be concave and like have a dent in, because it has to be inscribed in a circle, and it can't have a dent in it and be inscribed, because then not all the vertices would touch the circle. Okay? So when you can picture this on a circle, it kind of makes sense that the segment that connects the center of the polygon to the vertex, which would also be on the circle, is called the radius. Everybody see that? Okay. The weird little segment that connects the center of the polygon to the center of its side is called the apothem. It rhymes with opossum, which is a small marsupial. Okay, and then a diameter would of course go all the way across. So the apothem has a couple of special properties. It is perpendicular to the side, and it splits the side in half, so it's a perpendicular bisector for the side. So that picture got a little bit messy. Let's draw our own. So here I have a regular four-sided figure, also known as a square. A square. So this is a radius. Okay, if I drop a perpendicular from the center to the side, I'm bisecting the side. This is the apothem. Okay, and then this, of course, is our side S. Yes? It is a chord of the circle. Yes. All right, let's do another one. That one was so much fun. Okay. Here I have a cute little hexagon. Okay, here's my radius. Okay, if I drop a perpendicular from my center to the halfway point on my side, that is the apothem. And this is my side. Okay, so we are about to derive the formula for the area of a regular polygon. Okay, on my square, my regular four-sided figure, do you see that I could have made 4 of those little pink triangles? Okay, on this hexagon, you see that I could make 6 of these triangles. Everybody see it? Okay.
Is it the amount of sides for that?
It has to do with the amount of sides, yes. Okay, so let's concentrate first on this triangle. Tell me what the area formula for a triangle is. Yeah. Okay, so we know that the area for the regular polygon is going to have 4 or 6 or 5 or however many small little triangles. Okay, so we're going to call the number of sides n. Right? This is for the number of sides. Okay, and then the area formula for a triangle is 1/2 times the base times the height. What is the base of this cute little triangle? Yes, S, the side length, right? Everybody okay with that? I'll do it under. Okay, what is the height of this cute little triangle? The apothem. Okay. So, I have here multiplied together n triangle areas. Does it matter what order the n, the s, the a, the 1/2 go in? You can pick any order you like. I am particularly fond of NSA for the National Security Agency, that I believe no longer exists. So I like 1/2 NSA. You can do 1/2 A times N times S. The advantage of 1/2 times A times N times S is that the number of sides times how long the side is actually the perimeter. So if I know that the perimeter is the number of sides times how many sides there are, I can write it as 1/2 AP. So these are all equivalent. 1/2 NSA, 1/2 A times N times S, 1/2 AP. You pick your favorite. I don't care. They're all right. All right. Really quick before we move on, we are going to talk about central angles. Going back to these pictures here where you can see my inscribed pentagon, the central angle for the pentagon corresponds to the central angle of the circle circumscribed around it. That's exciting to try to say on video. So if I want to know what is the measure of this angle, how many degrees is in a whole rotation? But what if I only went 1/5 of the way? Because I have 1, 2, 3, 4, 5 of those cute little triangles. So I'm going to take my 360 and divide it by 5, which also is my n, my number of sides, and I get 72 degrees. You're correct. Okay, let's do a couple more before we go on. Oh, yep, okay. What about this one? What is this angle here? Well, it's my 360 rotation chopped into how many pieces? 1, 2, 3, 4 is 90. Okay, and then this is where it gets real exciting. If this one's 90, what is that one? You bet it is.
Because the apothem is perpendicular.
Yeah. It's, yep. All right, let's do one more. Okay, remember that I can make 6 triangles down here. Okay, so now my 360-degree rotation is getting chopped up into 6, making each one of these what? 60. My little antennae are perking up. I'm seeing 45, 45, 90s, and 30, 60, 90s. Are you guys seeing them? Okay, and that makes this angle what? 30. Okay, everybody get how to find the central angle? And then the angles made by the apothem? Okay. All right. So here I have a regular hexagon. Its center is what? Point R, right? Okay, we need to identify a radius. So a radius is a segment. So we could call it RK or RL. Kind of like RK. My capital L's end up looking very silly. Okay. We need to identify an apothem. Say an RS. And then we need to find the measure of the central angle. I'm busy. Okay, we just did this. We have a complete 360-degree rotation chopped into how many pieces? One. Okay, 6 pieces. You'll have to wait till we're done with the video. All right, 60 is correct. Easy peasy. Guys, we're cruising. All right, do you guys know which of the formulas you liked? What? I do too. That's the one that the other ones I don't remember so good. 1/2 NSA. Okay, why don't you guys see if you can plug in all of the stuff and I'll catch up with you. Let me turn this phone off because it's... Okay, so what did you guys say for the N? Yep. Side length S. Well, apothem. Yeah, that gross. All right, unless you feel like doing that by hand, I would put it in the calculator. I'm getting 247.749 inches squared. Does that look right? Okay. So sometimes the math gods smile on us and they just tell us the apothem and the side, and we just plug them into the formula with the number of sides. And all is not good in the world. Sometimes, because the math gods can be fickle, we don't have all of that information. So here we have a hexagon, and they're telling us that the radius is 16. Where should I put the radius? Going from the center to a vertex. So here's my 16. Okay, now I'm going to chop into my 6 triangles. I'm going to drop my perpendicular bisector apothem. where it gets fun. Because I need to know the apothem and the side length if I'm going to use my formula. So, do you see? I need my central angle. Which is 60. Okay, which makes this one what? The little 30. Okay, which gives me, I got a 30, I got a 90. I got a 30, 60, 90. Okay, so, do you see that this side is the short leg of my 30, 60, 90 triangle? Okay, and this is my hypotenuse. My radius is my hypotenuse. So somebody tell me what this bit is. It is 8. And that is really helpful for us because if we just double it, then we have our side length, which is 16. That was kind of nice. Okay, I have a 30, 60, 90. The apothem happens to be the long leg of that triangle. Somebody tell me what my apothem is. 8 root 3. You got it. So now I know all of the things. This is my S. This is my A. And my N is 6. So this is asking for exact and rounded. So my area is 1/2 times my number of sides, 6. I've got 6 triangles. The base of each of my triangles is my side length, 16. The height of each of my triangles is the apothem, 8 root 3. Okay, I think that this is where I left off recording, but I'm not positive. So if not, I'm really sorry. But I'm not fixing the whole video. I'm so sorry. Okay, so we are finding the area of this regular polygon. So we know that the 12 is our S. That's our side length. The A is our apothem. And our N is our number of sides, and that appears to be 5. So we're doing area equals 1/2 times 5 sides times 12 inches times 8.2583. So we just put that in our calculators. Okay, I'm getting area equals 247.749 inches squared. Okay, so that one was nice because they gave us the apothem, they gave us the side length. All we had to do was count the sides and plug everything in. Sometimes we've got to do a lot more investigating to get our side length and apothem. We'll do that next. Okay, for this one, we are finding the exact and rounded area of this regular polygon. So I need the number of sides, I need the apothem, and I need how long are the sides. And then I can plug everything in. So I already know that I have 6 sides, that's my N. And then I have to do some investigating. So I'm going to draw in my center. I'm going to make 1 or 2, let's make 2. I'll make 2 of my 6 triangles. Okay, I know that the measure of my central angle is going to be 360 degrees, which is a complete rotation, chopped into 6 pieces. So that is 60 degrees. Okay. Now I am going to drop a perpendicular bisector from the center of my hexagon to the center of my side. It is bisecting my side. and it's perpendicular to my side. That is the apothem. It's telling us that the radius is 16. The radius is the hypotenuse right here. If my central angle is 60, then this angle here is 30. And now I've created a 30, 60, 90 right triangle. So if this is 16, my hypotenuse is 16, the short leg here has to be 8. And now I have 2 8s, which give me a side length of 16. Now I just have to find my apothem. My apothem is the long leg of my 30, 60, 90 triangle. So it's just going to be 8 root 3. All right, we're going to plug in all the stuff. Area equals 1/2 times 6 times 8. Oh, I put this in a weird order. Okay, so I have 6 triangles. The base of my triangle is the side length of 16, and the height of each of my triangles is 8 root 3. So this is my N, my S, and my A. Okay, so we can just put that in the calculator. We're going for the exact one first. Okay, so my area is 384 root 3 inches squared, or approximately, says round to the nearest thousandth, 665.108 inches squared. Okay, next. All right, we need our N, we need our S, and we need our A. I'm counting 8 sides. Okay, so we gotta find this central angle real quick. Ew. Ew. So I need to know what 360 degrees divided by 8 triangles makes. I don't remember. I think it might be 45. Okay, it is 45. So my central angle is 45 degrees. Okay, and that's important because on here they have drawn for us this cute little triangle, and they've given us the apothem here. And the apothem is bisecting the side, and it's also bisecting this angle. So if the central angle is 45, this bisected angle, is 22.5 degrees. Okay, so this is where you need your trig. So I hope you paid attention in our last unit. Okay, we're back. Now you will notice that with respect to our 22.5 degree angle, our apothem is the adjacent side. Here, let me go and label this picture over here. Okay, this one we said was 22.5 degrees. So with respect to that angle, our apothem is the adjacent side. And then this cutie little side is the opposite. So I can use my trig to find those sides. Especially because they told me that my side is 4. So I know the S is 4. That's in the picture and here. So this is 2, this is 2, my opposite is 2. So I can use tangent, which is opposite over adjacent, and find my apothem. So tangent of 22.5 degrees is opposite 2 over adjacent apothem. And then I'm going to switch on my diagonal. Thank you, algebra. And I know that my apothem is 2 divided by the tangent of 22.5 degrees. I'm just going to treat that like a number, and when I put it in my calculator doesn't care that it terrifies me. It's a calculator. It's programmed to handle that weird number. All right, let's plug it into the formula. Area equals 1/2 times my number of sides times the side length, which is the base of the triangle, 4, times my apothem, which is 2, divided by tangent 22.5 degrees. The denominator for the 8 and the 4 is both 1, right? So when I'm looking at this and I'm like, I don't want to type all this in my calculator, I'm seeing that these 2's are canceling, right? So I can, in my calculator, I can just put in 8 times 4 is 32. So I can do 32 divided by the tangent of 22.5. You want to save your rounding to the end as much as possible. And the better you get at it now, the less it'll hurt later when it matters in engineering school. 33 divided by, let's all make sure that we are in degrees. I am. Okay. 32 divided by tangent 22.5. I'm getting 77.25. These are square centimeters. Okay, that was fun. All right, next, we get to draw our own picture. Yay! Hi. Okay, I'm going to do my best to do an equilateral triangle. Okay, that's not the worst. All right, we know that the apothem is 5 millimeters. So remember that the apothem goes from the center of, now don't make your center up here. It's gonna look like it's kind of low. So from the center to the side is 5. Okay. Now, I forgot to draw my little baby triangle in there. So I made, from my I need to draw my radius and my other radius. Ew. I'm really struggling pretty hard. I should have quit while I was ahead. All right, now we need to figure out what the central angle is. So like, what is this angle? Well, it's my 360 degrees divided by 3 sides and 3 central angles. So we're going to call that 120. Wow, that was not as hard as I made it. Okay, so that one's 120, which means that this one here is 60, because my apothem bisects my 120 degree angle. And if that one's 60, this one's 30. So I have here a 30, 60, 90, a pair of 30, 60, 90 triangles. They're just oriented differently in space. So the 5 is my short leg, and I need to know my side length. So if I'm thinking about my N, I have 3 sides. My apothem is 5 millimeters. I just need my side length. So I need this S. I can find part of it using my special right triangles. So I can find my long leg by doing 5√3. Okay, now if I have 2 of those, my side is 10√3. All right, so I'm doing area equals 1/2. My number of sides is 3. I've got 3 triangles. The base of each of my triangles is my side length, 10√3, and my apothem is 5. Okay. 2 divides 10, it goes in 5 times. So I have 5 times 5 is 25, times 3 is 75. So I'm getting 75√3 millimeters squared. Fun, fun, fun. All right, we've already done some composite figures, but our composite figures haven't had like regular polygons in them before. So we're supposed to find the area of this cute little composite figure. And you just find the areas of the parts. So I see a square, I see a regular hexagon, and I see what appears to be an isosceles trapezoid. So they're telling me that this side is 9. So it's marked as congruent to these sides, right? So I know that that little guy is a square. And 9 times 9 is 81. So this little square has an area of 81 centimeters squared. All right, let's start chopping up this regular hexagon. Here's my little 1/6 of my hexagon. My central angle, remember, is 360 divided by 6, which is 60 degrees. When I draw in my apothem, that 60 degrees gets chopped in half, creating a 30, 60, 90. So this is now 30. Okay, adjacent to my 30-degree angle is the apothem. Remember that my apothem is also bisecting my side, so if the entire side is 9, then this cute little part of my side, half of that side is 4.5. So I can find my N is 6, my S is 9, and my apothem is going to be 4.5 root 3. So the area for my hexagon is 1/2 times 6 times 9 times 4.5 root 3. Ew. What is... Okay, so I'm getting 210.444 approximately. So it's 121.5 root 3, and then it's approximately that. All right, just the trapezoid left. Okay, so one of my bases for my trapezoid is 9, and the other one is 15, and it looks like my height is 19. Okay, don't be confused if your height is sideways. The height is the distance between your parallel sides of your trap. So my area is 1/2 times my bases added together, so the average of my bases, times my height, which is 19. I'm getting 228. So my total area is my area of my square plus the area of my hexagon. Let me just call that S. Plus the area of my trap. Which is approximately, if I add those up, $519.44. What does it say to round to? It doesn't. We're just going to go to the thousands because it's easy. These are centimeters squared. That's it. All right, that one was so much fun. Let's do another one. So for that composite figure, we had to add up a bunch of figures. On this one, we are going to subtract away a figure. So I have here a trapezoid with a triangle removed. So our area is going to be the area of our trap minus the area of our triangle. Okay, let's figure out what those two pieces are. So the area of our trapezoid, let's start there, is going to be the average of our bases, 1/2 plus 5 and 5, this looks like 12 to me. 1/2, 8 plus 12 times our height, and we don't know our height yet. Okay, and then let's find the height of the triangle first. All right, I'm going to redraw it. So I have here 2 meters and I have 6 meters and 6 meters. I just don't know that I need the M on there right now. I just wanted this to be, okay, so that's 2. So if I were to make a right triangle, this would be 1 and 1 for a total of 2, right? Okay, so it looks like I can Pythag this and get that other leg. So, what do we want to call that? Let's call it x. So x squared is going to be 6 squared minus 1 squared. So x is 36 minus 1, 35. Okay, so x is going to be our square root of 35. So that's this. Now, it looks like I also have a 1 meter right here. So the height for my trapezoid, this is nasty. Sorry, guys. My height for my trapezoid is going to be 1 plus root 35. Okay, that was fun. All right, so I'm doing 1/2 times 8 plus 12 times 1 plus root 35. Ew. Okay, I'm getting 69.16. Okay, now I need the area of my triangle. Okay, this should be easier because we already know the height of the triangle. So the area of the triangle is 1/2 times our base times our height. So the base of the triangle was 2 and the height of the triangle was root 35. That's just root 35. Okay, so I just have to subtract the root 35 from the 69.16. Okay, so our total area is 63 point, so round to the nearest tenth, so I'm doing 63.2 meters squared. Yikes. That did not look so gross when I picked it. Is that the end? Yeah. All right, we're done, Zoe. You survived.